The integral that you see on the screen right now confuses 99% of the students that I know, and it is a very important integral in various university calculus exams as well as various entrance exams as well. So make sure you watch this video till then to see how to integrate that function on the screen right now. In order to integrate 1 over x to the power n minus 1, the general rule says you multiply and divide by x to the power n minus 1, and then you can do the U substitution. Nobody on the entire YouTube is going to teach you about this general rule. Okay, so make sure you hit that subscribe button. Now let's see how do you apply that rule in this integral. Here, if you see x to the power n, so n in this case is 4, so you have to multiply and divide by x to the power 3. Okay, so let's multiply and divide this integral by x to the power 3, and then we'll have to do U substitution. So we have x to the power 3 divide by, when you divide by x to the power 3, this is going to become x to the power 4, because there is already one x in the denominator, and x to the power 4 minus 1 with respect to x. I hope that makes sense. Now what you have to do is, if you notice carefully, the denominator is now in terms of x to the power 4, and in the numerator you have x to the power 3. If you end up putting the denominator term, let's say x to the power 4 minus 1 is equal to u, you have the differentiation of x to the power 4, which is 4x to the power 3 is the cubic term in the numerator. Let's see how do we benefit by that U substitution. So put that x to the power 4 minus 1 is equal to u, because we know the x cubic term, which is the differentiation of this power 4 term, is present in the numerator. So we benefit by doing that U substitution. So let's differentiate both the sides with respect to x. So the differentiation of x to the power 4 is 4x to the power 3 is equal to differentiation of u is du by dx. Now if you notice over here, x cube dx, we also have here x cube dx. So in order to convert that integral from the x world to the u world, we can use that. So therefore, just multiply the dx over here, take that 4 over here. So we have x cube dx is equal to du divided by 4. We can use this equation to convert that dx in terms of du, because we know x cube dx now is du divided by 4. So what you have over here now is integral. This two terms again combined is du divided by 4. Okay, and then that x raised to 4 minus 1 is nothing but u. Remember, we also have that x to the power 4. If you look at this equation, the value of x to the power 4 is nothing but u plus 1. If you just add 1 on both the sides, or take that minus 1 on the right hand side, that x to the power 4 is u plus 1. So we have u plus 1. So this term over here, this x to the power 4 is this u plus 1. This term is this u, and that x cube dx is nothing but du divided by 4. So that's how we convert that integral from the x world to the u world. Now that 4 is constant, can be taken out of the integral. So we have 1 by 4 integral of du divided by u times u plus 1. Now what you have to do in order to integrate this is partial fractions, because the denominator is in terms of factors and the power of numerator is less than the power of denominator. That's a classic example of partial fractions. So in order to do partial fractions, what you say is, let 1 over u plus 1, express that in terms of a divided by the first term, which is u, plus b divided by the second term, which is u plus 1. Now let's find the values of a and b. Now in order to find the values of a and b, what I like to do is assume some random values of u. Many people also like to compare this equation on both the sides and find the values of a and b. It's not incorrect, but I find it extremely inefficient. What is efficient is you can just assume some random values of u, and I like to assume the values that will make my calculations easy. Let's see what do I mean by this. So for example, if you put u is equal to 0, this term is going to become 0. So let's start with u is equal to 0. So if you put u is equal to 0, what's going to happen is 1 is equal to a times 0 plus 1 is nothing but 1. Okay, and this is essentially 0. So what you have is a equals 1. How easy was it to find the value of a? Now let's see similarly how to find the value of b. What you do is you try to make this term is equal to 0. So if you put u is equal to minus 1, this term is going to become 0. So let's put u is equal to minus 1, and what you have is 1 is equal to, so if you put u is equal to minus 1, this is 0, Okay, and then you have b times minus 1. Okay, so therefore you have b is equal to minus 1. How easy and efficient was it to find the values of a and b? Now we can substitute those values of a and b in this partial fraction equation over here. In fact, we can rewrite our integral. So our integral, let's say if it was I, will become a over u, which means 1 over u, and b over, which means minus 1 over u plus 1. And we have with respect to, sorry, we are integrating with respect to u at this point. Now it's very easy to integrate. We can just give that integral to both of those terms. So we have integral of 1 over u with respect to u minus integral of 1 over u plus 1 with respect to u. Okay, now we know integral of 1 over u is nothing but ln u. So this is ln mod u minus ln mod u plus 1. Okay, since the coefficient of x is 1, you can divide by 1 if you want, but it doesn't matter. But remember, in case of linear terms, you have to divide by the coefficient of x after integrating. Now what you can do is resubstitute the value of u and convert it back to the x world. So we know the value of u was x to the power 4 minus 1. So the value of u is x to the power 4 minus 1. So let's resubstitute that. So we have ln x to the power 4 minus 1 minus ln x to the power 4 minus 1 plus 1, because that plus 1 is already there over here. Okay, plus constant of integration. See, this minus 1 and plus 1 will get cancelled. We can clean this up a little bit using the properties of logarithm. So we have x to the power 4 minus 1 minus ln x to the power 4 plus c. We know ln a minus ln b is nothing but ln a divided by b. So x to the power 4 minus 1 divided by x to the power 4 plus constant of integration c, and this is nothing but the final result of the integral that we are looking for. In this video, we not only learned about how to solve this integral, but we looked at how to solve any general integral which is of the type 1 over x times x to the power n minus 1. Essentially, what you do is just multiply and divide by x to the power n minus 1, and then do the U-substitution and then do the partial fractions. If you want to see more such calculus and math hacks in general, please don't forget to hit that subscribe button. I do post math and calculus content every single day. If you don't want to miss the regular updates, hit that subscribe button. See you tomorrow.